In the last video, we began to understand the structure of a network. Now let's explore how devices actually communicate and what ensures that messages get to where they're supposed to go. So first off, we got to look at protocols. Simply put, a protocol is a set of guidelines that specifies how information should be formatted and sent between devices. Consider it as a language that both parties need to be able to grasp in order to communicate effectively. Without protocols, a message from one computer would appear to another as just random noise. Think of this as like a greeting between two people, where one person might say, "Hello, how are you?" to which the next person would respond, "I'm good, how are you?" In a similar way, we can see where our first device is going to request something, and then our second device is going to either accept or reject that. So it's just like a conversation between two devices. So common internet protocols. Some of those significant protocols are as follows. When you surf websites, your browser is going to use a hypertext transfer protocol to request pages from a web server. The basis of all internet communication is transmission control protocol / the internet protocol, which makes sure that your packets are sent, received, and arranged correctly. And then we have the phone book of the internet, or DNS, the domain name system, which converts domain names that are readable by humans, such as google.com, into a computer understandable IP address. For example, if you type in www.youtube.com, HTTP will gather your video data and send it to your device. TCP will establish a dependable connection, and DNS will locate the IP address. So now network performance. There's four important factors. First off, we have delay or latency, which is the amount of time it takes for data to go from the sender to the recipient. When packets are entering the queue more quickly than the router can send them, this typically occurs. Next up, we have packet loss, which is when certain packets are never delivered to their intended location. This typically occurs when there's so many packets in the queue that some get dropped. So the amount of data that can be sent per second is known as throughput. Typically, throughput is expressed in megabits per second or bits per second. A high throughput denotes effective routing and data processing, which results in a quicker and more seamless network experience. Your ISP plan, router capabilities, and connected devices all have an impact on your bandwidth, which is the maximum amount of data that your network can send, it's also measured in bits per second. We're going to look at three primary types of delays. First off, we have the transmission delay, which is the time required to push every bit into the wire. Next up, we have the propagation delay, which is the time it takes for signals to go through a medium. And then we have queuing delay, which is the waiting time in the router buffers before network congestion. Some websites load more quickly than others because each of these factors affects the overall time it takes for your data to arrive. So as we can see in this picture, we have our queuing delay as the packets stack up. We have our transmission delay as these are waiting to get passed onto the wire, and then your propagation delay, the amount of time it takes to get sent to the next router. Next up, we have throughput and packet loss. So similar to water flow in a pipe, your throughput will quantify the amount of meaningful data that is carried over time. When that pipe gets clogged, your packets are discarded, which results in packet loss. And to maximize performance, network engineers continuously track these variables, particularly in large enterprises and data centers. Next, we're going to look at some network security and threats. So the most prevalent dangers that can affect computer networks include DDoSing, packet sniffing, and IP spoofing. These can occur anywhere, whether it's in a home, on a public Wi-Fi, or in major enterprises, despite the fact that we frequently take network security for granted. So first off, we're going to look at IP spoofing, which is the practice of an attacker forging a packet's originating IP address to make it appear as though it's from a reliable source. This is done to reroute traffic, get around access restrictions, or conceal your identity. It's comparable to receiving a letter from a stranger that you believe to be from a friend, but it actually has a phony return address. Next up, packet sniffing is the process of intercepting and capturing data packets as they move over a network using specialized software or hardware tools. The attacker can view your private data, such as credit card numbers, usernames, and passwords, if the data is not encrypted. An attacker can also block legitimate users from accessing a server or network by flooding it with excessive traffic, which is known as denial of service. And then very similar is a distributed denial of service, which uses several computers, frequently a part of a botnet, which will attack your servers, flooding it with bogus traffic. These are only a few instances, but they demonstrate how hackers might take advantage of holes in a network to steal data or do harm. Security procedures such as encryption and authentication, which we'll talk about next, are therefore crucial for maintaining network security. Data that's been encrypted is guaranteed to be unreadable by anybody other than your intended receiver. For instance, HTTPS employs encryption to prevent unauthorized access to your communications or passwords, even in the event that your web traffic is intercepted. And then authentication, which frequently uses passwords, biometrics, or tokens to confirm identity, that you are who you say you are, which therefore prevents some of the security risks. So to improve network security, we can stop unwanted traffic using firewalls, use VPNs to connect securely from a distance, update your program to fix vulnerabilities, make sure that users have multi-factor authentication and strong passwords. This is particularly on networks at home or in small businesses. Even just these things can have a significant impact on your basic security. Now let's just review what we've learned in these last two videos. As a network of networks, the internet will connect billions of devices worldwide. Data flows defined by the network core and edge. TCP, IP, DNS, HTTP, and other protocols enable communication. Delay, loss, and throughput are performance indicators that are used to gauge the health of a network. Additionally, firewalls and encryption are security methods that can guard against threats. Gaining a solid understanding of these fundamentals enables you to investigate more complex topics like network management, cloud computing, and cybersecurity. Thank you for watching, and check back soon for more videos.